Hey everyone, how are we doing? I see we got a few questions. Can we go over Project 2 slowly? Which portion of Project 2? Mention which portion. Let's ask, can we go over Chapter 16 homework quiz? You bet. Which one? And the first question right here, I see, make sure to be like specific. Hey, can we work on this part of Project 2? Can we talk over this? And I see Kayla says, can we go over Chapter 17 math exams, June and August? So that's the first one we got right here. So mention which thing you want us to go over like specifically, and that'll help a lot because then we'll go into that and go very, very specific on it. So we're going to load up Pearson right here. And thank you, everyone, for being here. I think Mewbot's awake. Let me wake up Mewbot. He needs to wake up every once in a while. Re-waking up Mewbot right here. So we are going to do some chapters 17. I see some chapter 16 too. So be like, which specific one do you want to do? Which problem are you looking at? And we will start doing that. Or which thing on the project? And we will start looking at that. Here we go. Chapter 17. What part do you think is the best to start with? I have no preference. Like one of the first. So pick one. Like one of the first. There we go. Oh, thank you so much, Josephine. Great stuff right there. Yep. We went over the Z test. So checking that out. Really good stuff right there. And yeah, I think that's an excellent way to do it. The Z test. That we did on the 10th. But whatever you're working on, be like, hey, can we go over this one right here, the Z test or the 2 sample? And then we'll go over that and make like a section of the video. So Josephine, thank you so much. 100 points right there. We got right there. Exactly. Awesome stuff. Great suggestions. I think I found the math exams June and August. Oh, wait, this is a different one. This isn't traditional, non-traditional. Math exams June and August. You can do it. I would do the executive summary last. Good to see you here, Ivy. I would do the executive summary last because you can't really write the executive summary without doing your report. So that's the only thing I would do last is the executive summary. Here we go. Let's go check out. This won't be a long one. So we got next questions ready to go. I think Tiffany, if you were the first to ask. Tiffany, if you have a specific thing you want us to cover. If not, let's do the one sample. You got it, Tiffany. That'll be next. Here, let's hop into this. Having done poorly on the math final exams in June, 6 students repeat the course in summer school, then take another exam in August. Now, I want you to think about this. So let's say you make a 90 on exam 1. Then your next exam score would be what on your previous exam score? So when you think about this, if you have students who have are retaking a class and they took an exam in June and then they retake it in August, and you kind of see this with the data, what do you think about their August scores with their June scores? And I'll give you a hint. We were talking about this at the very end of class today. What do you think about their August and their June scores? What do you think about their August and their June scores? Like you have their June scores and their August scores, and probably those scores would be what between each other? Be careful, not quite that. But what do you think between their June and their August scores? Thank you so much. We got some great questions lined up. Kylie, thank you so much. What do you think between their June and their August scores? So you'd say, okay, someone's retaking a test in August, then their score in August is probably going to what on their June score? So you know, like someone made a 20 in June, so it's going to be tougher in August because they got a lot of ground to cover, but someone made like a 60 in June, so okay, wait a minute. So their June score and August score would be kind of what on each other? And so this is a condition we need to pass, but we're not going to pass it here. What do you think about their June and their August scores? Am I still on top chat? No. So their August score would what on their June score? So you're retaking a test in August and you took it in June, and this is student 1, made a 54 in June, made a 50 in August. And so probably what they make in August is going to what on their June score? And this violates the 4th condition of random, 10%, nearly normal distributions, and then we want them to be independent of each other. So this is actually an example of dependent means. So in this example, somebody's August score would depend on their June score, and so because of that, we don't pass the conditions to do this. So these are before and after scores for the same individual, not independent samples. This violates the independent group pass. Yeah, we'll definitely do that. Good question right there, Kylie. That should do it. Yay! I got worried. Last week I was like off my game. We're not having it happen this week. Not happening. So this is the 4th condition right here, independent means. And there are a lot of examples where there are independent means, like there's the popcorn example right here. So kind of a quick extra one on this, but this is two groups of students bringing home a bag of popcorn. One student puts it in the freezer overnight, and the other students, or a bunch of students, put it in the freezer. Oh, no worries at all. I don't think it happened to anyone else, but no worries. This is an example. Imagine 20 students bring home a bag of popcorn, pop it overnight after leaving it on the counter. And another group of students, 20 of them, bring home a bag of popcorn and pop it after putting it in the freezer. Yep, no worries. And so this would pass the conditions below to do two means, because these groups are independent of each other, because the bag of popcorn that is left on the counter would not depend on how many kernels are popped for the bag of popcorn that's in the freezer. Because think about this, you have a bag of popcorn that's put in the freezer by one group of students, you have a bag of popcorn that's put on the counter, and those how many kernels pop are independent of each other. That's different than the previous example here, when they're actually dependent means on where we have one group, the student took the exam before and after, because now what a student makes in August is going to depend on what they made in June. So this is a good example of dependent means right here, where the second mean, the average in August, would depend on what a student made in June. It's the same student. So if a student did poorly, then they might do poorly again. Where if a student did a little bit better, they might do better here. So you see more dependency here, and that's a violation of the fourth condition, where here you have independence. So good examples right here of when we pass the fourth condition, which is independent means right here. Great stuff. Load it back to the main screen. So we're going to do a t-test here, just a t-test. Tiffany, would you be okay if I actually did the two-sample t-test to follow this up? So we could do the two-sample t-test and talk over this. Or Tiffany, you pick one or two sample t, because we were just doing the one sample t right there. Oh, I actually got Jump 16 to install this weekend. I literally had to do so much legwork because I had to literally like send it to myself via Google, because I got it to download on my Mac, and then I had to like send it. Let's do both. We'll do the two sample to start, then we'll circle back around here in a little bit and do more questions, because there's a bunch of other questions. So we'll do the two sample, which is connected, so you can do the project in parts. Thank you so much. Yeah. I said, let me load up Jump 16 right here. I finally have Jump 16. It took a while. Wait to register. Never register Jump. All right. Oh, wow. So small. Wow, it's loading quicker. Okay. We got this right here. Let me get the project instructions up. Again, the project instructions up. And project instructions downloaded. Got everything, so many things opened. Okay, let's go ahead and check out the project. We'll start with the two sample here, because it's connected to what we're just doing. About the hiccups. And let's go check that out. Two sample T on the project. Here we go. So once again, you can do this project in many different orders. Turning it in late has a 15-point penalty. There is 8 points for turning it in early, so get it in early. Lots of points right there. Make sure to write your prompt that you're working for a certain company and you're analyzing a variable of your choosing. I'm using a different data set than everyone will be using, so I'm going to kind of do my own examples right here. All this good stuff here, we're going to go down to the two sample t-test. Now, one thing I want to point out is when you're doing the project, do I have it up? Look over the rubric. Look over the rubric, because the rubric is going to tell you where all the points are allocated. So I cannot state this enough, that if you are wondering, like, am I doing well on the project? Am I answering all the questions? The way to know you're answering all the questions, and here's the data sets you'll be using with kind of instructions of what the data sets are about. I'm using a different data set. There's the project 2 instructions. Yeah, definitely. We can do that here in a little bit. We'll do it during, we've done it before, but we can do it here again in a little bit, Vincent, you bet. And so here's the different data sets. And then we're doing the two sample t-test right here. You see one sample t-test, one sample, two sample. So there we go. We first need to make a graphic that is easy to read and has numeric backing. So all this great stuff. Kayla, you are awesome. Thank you so much, Kayla. So we have display the results of a two sample t-test. Graphic is easy to read and has numeric backing. Okay, cool. Let's go back here. We're going to pull up our data over here. And so what do we need to do? Make it bigger so even I can see it. There we go. And now a two sample t-test has two variables. Now this might be odd to think about, but the X variable needs to be what? If we're doing a two sample t-test, like let's say I want to compare the high school GPAs of males and females. So the x variable for a two-sample t-test found under analyze fit y by x. This is the two-sample t-test. Analyze fit y by x. The x must be a what variable? So I'll give you a hint. I'm going to analyze people's high school GPA by their gender. So the x variable must be a what variable for the two-sample t-test. This is where we got to today. We'll be finishing it next class. But the two-sample t-test has an x variable that is a what variable? Very important things to know right here, because we're going to analyze the difference between two means. That's what a two-sample t-test does. T-test is for means. Two-sample means two groups. Good guess right there. Good guess right there, Josephine. 100 points. The x variable is actually the categorical one. So you see here, gender with the red right here is categorical. And then we have here the y variable of interest, which I said would be GPA for my example, is the quantitative one. Does that make sense? So we have here gender is a categorical, and we can see this from the notes. In the notes, you will see here we have whether someone is a freshman or junior, which is a category on the x-axis. And then we're looking at, on average, how many Facebook friends they have. Other examples are, is someone a friend or a stranger? So this is on the x-axis. And then we have how much do they sell you a camera for? Then we have right here, is it a brand name battery or a generic battery? And how long does it last? So the y variable here is quantitative, just like we're doing right here, where the y variable is quantitative and the x variable, which kind of splits it apart, is a two-level categorical. So we're going to compare the average GPA for males and females. Does that make sense? This is comparing the average GPA for males and females. Let's go here and click OK. This was found under Analyze Fit Y by X, and then we can compare these two means. So now we get the following. Now this is not so interesting. Go here to the red arrow, and I'll pause on this. This has all the options we're looking for. We're going to click on two of these. There's so many new buttons. I just noticed a new button, local data filter. I don't even know what that does. We're going to first go to quantiles. And what do we see here once I go to quantiles? So I'm going to pause right here. And going to quantiles, what do you think we get right here? Does it show you? It doesn't tell you what it gives you. You're about to see it. What did we just get for our data? What did we just get visually for our data? We just added what to this? I'm going to see if it asks for this. I like to show this. I like to show the quantiles. There's a little bit of difference. A little bit of difference between medians. We're not going to analyze this. What do we notice right here? What did we get visually? Which you can see. 5-number summary, yep. And we got a little extra too. We got the 10%, the 90%. 5-number summary, the min, the Q1, the median, the Q3, and the max. Kayla, great review right there. 5-number summary. It shows the 5-number summary in the box plot along with the 10% and the 90%, which are quantiles. Like quantiles just means like percentiles on the curve or percentiles on this distribution. Like the 90th percentile of GPAs for females was a 4.3. But now let's go here to the red arrow again and go to t-test. Let's go to t-test. And no graders should take off for you showing quantiles. It's the easiest way to get some box plots, which I think makes it a pretty nice thing to see. And nothing wrong with showing that quantiles right there. Let's go here to t-test. Now, what do you think the null hypothesis would be for the difference between male and female GPAs? It'd be that the mean for males minus the mean for females has what different female GPAs? Like female GPAs and male GPAs have what difference? What would be a good null hypothesis? I'm going to write it right here, actually, before we click it. We're going to click that button in a second. But the null hypothesis would be, and I don't think we have to write this. I'll double check. Oh, I'm on highlighter. The null hypothesis would be that the difference between male GPAs, and no, it'd be female and male. It's alphabetical. It'd be, because it does alphabetical. No, it does reverse alphabetical, doesn't it? It does reverse alphabetical. I'm going to cheat and see. I think it does reverse alphabetical. It does do reverse alphabetical. I'll show you that down here in the output. Yep, exactly. Alexander, great job. Expected to be 0 as I mumbled to myself. The mean for males minus the mean for females is equal to 0. And the alternative would be that the mean for males minus the mean for females, if we're testing to see if there is a difference, is that it is not equal to 0. And this can be found in this output right here, kind of, sort of. Let me explain something. This is highly important. This is the way the difference goes. So when you look at males minus females, what does the negative difference imply to you? What does, and this is your screenshot. Don't include the things I wrote, but this whole thing right here would be your screenshot. What does the negative difference imply to you that you saw with the sample means? Let's label this. What does this negative difference imply to you? What does that negative difference imply to you? Explain to me in the chat right now what that negative difference implies to you. Connect it down there. Aloha, Diddle. Great to see you here. The females have a higher mean than males on average from the sample. Exactly. It's so females had on average a higher mean than males from the sample. Does that make sense right here? That now it might be evidence that females have higher GPAs, which it is going to be evidence in a moment. But we have in the sample that females had on average a higher GPA by about 0.15. And why do you know that? Why do you know that? Why is it that females had a higher difference than males? Why is that the case? It might be hard to see right there. Let me blank this out. Why do you know that this difference right here implies that females had a higher average than males? Why do you know that? Why is it that the females had a higher average than males? Why is that the case? What about this difference right here? Because it's negative. You couldn't say better. Yo, good to see you here, Jacob. The difference here being negative implies that the second one, if you notice, females are connected to the negative right here. And since the difference is negative, then we have evidence exactly, Jacob, and both, Kayla. Great job. If males minus females is negative, then females is the larger one. Exactly. It's like 8 minus 10. Well, then that'd be -2. So the second number is bigger. So if you notice the difference is negative, and sometimes I make mistakes on this, it can happen. Double check my work. If the difference is negative, that means the second number was bigger. And of course, look at the output and be like, yeah, it kind of looks like these are medians, but it does look like the female distribution is higher than the male distribution. I would say 2 to 3 hours. 2 to 3 hours. We're going to do the 2-sample t-test. This is a good 20, 25 points of the project right here. Good question, Chloe. And so what do you notice? Kayla gets that joke. What do you notice right here about our interval to estimate the true difference? The interval, and this is like the meat question. Remember that meat question about meat and beef hot dogs, which aren't those both meat hot dogs? What do you notice right here about this difference right here in this interval? The difference for this interval is estimated to be completely negative. So what do you notice is not in this interval? Do you remember our null hypothesis? We hypothesized that the difference between males and females was equal to 0. And 0 is not in the interval. So what does that mean we can do for the value of 0? You could what the value of 0 now? Who wants to tell me what you could do to the value of 0 on the two-tailed test? I'm doing this color. You could what the value of 0 now? Look at that test right there. Oh yeah, I would definitely copy paste it. I'm not showing that portion, but yeah, definitely copy paste it into the Word document, do the write-up. We can reject the value of 0. Well, one, because 0 is not in the interval, so we have evidence of a true difference, but then also the p-value here, the p-value is less than 0.05, so p-value less than 0.05, which is our alpha level, and so we have evidence to reject the null. Let's take a look over the questions here and see if there's anything we missed, because knowing this output is very, very important. I do want to do one more thing with this output. Let me copy paste it to a Word document real quick and just mention a few other things. Because I want to use this as like a teaching moment here too, to make sure people understand, if you see this on the test, what it all means. So we have to know, what does it mean? Here's the output right here. Look, exactly. Great job, Kayla, right there, 100 points. A lot of this test is very repetitive in a good way. That if you understand what you would do with p-values, you know what to do right here. So this difference right here, and this is very important for the test and for the Canvas content coming up, this difference right here is y bar 1 minus y bar 2. That is the difference between the sample means right here. The standard error of the difference right here is the complicated formula s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. Not too complicated. But when you look at this right here, how could we get the t ratio? Who knows how you could figure out the t ratio, which the t ratio is the equation t equals y bar 1 minus y bar 2 over square root s sub 1 squared over n sub 1 plus S sub 2 squared over N sub 2. So who knows how we could get the T ratio there? And this is something that is on the test quite often. Who knows how you could get the T ratio, which we are looking for right here? How could we figure out mathematically that T ratio? Who can solve like this? This is on the test. It's on the Canvas content also. If we could blank out that T ratio and say solve for the T ratio. And I love that question because you're like, oh, it's just the difference standardized. So how could you, the difference right there is y bar 1 minus y bar 2. That's just the difference between the two sample means. The standard error is the formula s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. So how mathematically would you solve for this number if it was missing? How could you get that 5.409? And so look at what we've written right here in notation. Look at the color coding. I think the color coding should help. So this is really good. This is Canvas content, understanding what we have right here. It's the T. So what do we have right here? What would that T, how would that T be found? I'm going to take my difference. There's the difference. And I'll just do what to my difference? So there's the difference right there. That is the difference. And then I'm going to do what to that difference? No worries, Kayla. I'm going to do what to the difference to find the T ratio right here. I've got my difference. And then how could I take my difference and turn it into a T ratio, which would be standardizing the difference? Very important to know for the test for the Canvas content. How could I take that difference right there and then solve for the value right there? Exactly. Divide by the standard error of the difference. Alexander, great answer right there. We're just going to divide by this because that literally is the formula. And there you go right there. There is the T ratio. There might be some extra numbers. So here you go, Kayla. Really good and good thing for the test and Canvas content. If you divide these two numbers, it equals this number right here. Because the difference divided by the standard error is the T ratio. Like this is the difference. And this is the standard error right here. So the difference divided by the standard error is the T ratio. So this divided by this is this. Does that make sense? Because it's just the difference, which is this. That's the difference right there. And then the standard error is the bottom portion. And that is the standard error. So the difference divided by the standard error is the T ratio. Really good stuff. Good things to see. Like you're like, oh, well, it shows you in the output the difference. Y bar 1 minus y bar 2 that's what that number is. Once you see, you're like, okay, that's the difference between the two sample means. And that's the standard error, which is basically like a standard deviation. Let's check the project right here to see if we have everything we need to talk about. And here's the two sample T. You know what? I'm going to go to the rubric. I keep saying, look at the rubric. So we have right here, we have a graphic that's easy to read. I know, right? Looks very familiar. Next, we need to clearly explain to the reader the point of the test you are performing and why it's important to the company. Okay, cool. Sure, my company is called Brian Stevens Incorporated. Now everyone's going to call it like their company, Brian Stevens Incorporated. Don't call yourself as Brian Stevens Incorporated. And we're here to tutor students. So I'm sorry, guys, but we might do more marketing to men. We might try to find... So think about this. We're trying to see if there's a difference between males and females in their GPAs. And we have evidence that there is a difference that, there is evidence that men have lower GPAs than females on average. This is real data. There's evidence that men have, on average, lower GPAs than females by about 1/10 of a point to 2/10 of a point. Like, I'm 95% confident the true difference between males and females' high school GPAs is somewhere between females having between 0.1 to 0.2 points higher on their GPA. Doesn't mean all, like, this male right here did really bad, but this male right here did really good. That's probably me down there, and that's probably my brother way up there. And then we've got over here a female who did poorly and a female who did great. There's variation within this, but on average, males do worse than females, and we have evidence of that. So we might try to market, why would this be important to my company? Well, if we're trying to help out people with tutoring, we might try to reach out to groups of guys or something like that to say, hey, we're offering tutoring services. We're going to reach out to everybody, but we want to see if maybe we should focus some efforts on certain groups that have lower GPAs, because if we're helping with tutoring, then lower GPA people are probably the groups we want to go to. And so men look to be more applicable right here. Now, we wouldn't know that till we did the test, but I'm doing the test to see if, maybe we should focus our attention on, reaching out to guys or girls, and it looks like we need to reach out to guys. So right here, without using statistical notation, explain the null and the alternative to your hypothesis test. So who here, I'm going to talk to you about this. I'm going to write it out again for you. Here is the statistical notation. It says don't use it though. So it says don't use the statistical notation. Exactly, Kayla, great answers right there. Here is the statistical notation. It would be, I don't want to use that color. The statistical notation is that the true mean for males minus the true mean for females is equal to 0. The alternative hypothesis is that the true mean for males minus the true mean for females is not equal to 0. What are you assuming about the difference between males and females GPAs to start? What are you assuming about the difference between males and females GPAs to start right here? So what is the starting assumption about their GPAs? Just explain, don't use the statistical notation. No, don't do that. Don't do that. I'm going to put a no next to this right here. No, don't use the statistical notation. What are you assuming about their differences? They're the same, right? That there's really, like, you could say that to people, like, we start out assuming that there really is no difference between males and females GPAs, that we should see very close values. Don't write out these things I wrote out right here. Don't do this. Don't do the notation. We're not asking for that. There's no difference, right? And so there should be no difference. Like, according to the null, the true difference between, and think about this. Watch this. If you do some algebra, what do you get? Do a little algebra right here. Algebraing this out gives you the following, that they're equal to each other. Does that make sense? Like, if you just moved the female GPA over to the other side, you'd say, well, the null is that they're equal to each other. And that's what no difference means. If we hypothesize there is no difference, then we're saying that they're the same. Like, males have about the same GPA as females, or we could just say, I wouldn't say about the same because that's not what we assume. We are assuming that there is no difference between males and females GPAs. So what's the alternative? The null is that there is no difference. The alternative would be that, which we found evidence of. We found the evidence for the alternative right here. That's very strong evidence. It's ridiculous evidence. That's like, yeah, is it practically significant? It's about 1/10 of a point to 2/10 of a point. I mean, 3.7 to 3.8 or 3.9 is pretty big. I'd like to get a 3.9 GPA. No. So the alternative would be that there's what? The null is that there is no difference between their GPAs. And like that says does not equal to, but we don't usually talk that way if we talk about differences. We would just say, well, we assume that there is no difference between their GPAs. And then the alternative would be that there is what? What would the alternative be? Which we did find evidence for in this test. Oh, that'll be from the very start. We could go over that a little bit later. Like, that'll just be your imagination. Imagination. Just whole imagination. There is a difference. Exactly. There is a difference. And so you'll come up with whatever company you want with whatever you're testing and then just apply with it. It's all your imagination right there. And so this right here would be an alternative that there is a difference. And that's how we'll explain it to the company. Just make up whatever you want. And so let's look to see any other parts we're missing right here. 2 sample t-test result. Explain the conclusion. Yeah, exactly, Alexander. Great job, Alexander. Explain the conclusion your company makes about the test and how they arrived at their decision by using the confidence interval. Oh, well, that's easy. How can I explain my conclusion to somebody using this confidence interval right here? What do you notice about my confidence interval? Here, we'll zoom in on it. Yes, that has a GPA on it. Yeah, you can use it twice. Great question, Tiffany. You can use it twice. A lot of people have asked that. You can use it for the same variable twice. That's totally all right because there's the t-test and the 2 sample t-test. Yeah, which kind of makes sense. A company might do that a lot of times. So how can I look at this interval right here and conclude that there is a difference? Because I think the difference is somewhere between females having a higher GPA by about 1/10 of a point to about 2/10. If I'm interpreting it to a company, I'm going to say, we are 95% confident. If I'm writing it, I'm going to write the 0.09546 to 0.20423. I would write it that way if I'm putting it in a report. But if I'm talking to my bosses right there, if I'm talking to my bosses, I would say something like, we're pretty confident, 95%, that the true difference between the GPAs of males and females is probably somewhere between females having about 1/10 of a point higher to 2/10 of a point higher. And this leads us to believe that there is a difference. Why? This leads us to believe that there is a difference because I'm saying I think females have between 0.094546 points higher to 0.20423 points higher, untruth average higher. And I'm 95% confident in this estimate. And I'm pretty confident there is a difference because my interval does not contain what, which was what I assumed to start. I assumed there was no difference, and that value is not in my interval. The value of no difference for me here is not in the interval, and that value of no difference is what? That value of no difference was what? And it's not in the interval. So I reject that value. I think that value is not true. The value of no difference is what value? And it's not in this interval. So if you look at your interval right here, remember we assumed, and I'll give you a hint. Oh, it does zoom in. I didn't know until I used the Epic Pen on this screen. So we are rejecting it, correct. And what was the value what value are we rejecting? So the null hypothesis is, don't write it out, that the mean for males minus the mean for females is equal to 0. And if you look right here, 0 is not contained in this interval. Does that make sense? Exactly. 0 is not in the interval. So you're saying, I don't think 0 is a value that is the truth. I reject 0. And that coincides with these results right here. So you're using the interval to look at it and say, is 0 a possible value of the true difference? No, we have evidence that females and males have a difference that is not equal to 0. And that's what I would explain to my company. Like, there's very strong evidence right here that the difference between males and females GPAs is not equal to 0 because it's not contained in the interval. Furthermore, it looks like females have a higher GPA on average by about 1/10 of a point to 2/10 of a point. And so maybe we need to do some more marketing to males. They might be in more need of tutoring. Sorry, males. I'm in that group too, so don't worry. It's all good. And that's the 2-sample t-test. Really good stuff on this and great review of the concepts we'll be going over next class. And Kayla, does it feel like more of the same? Like, hopefully this doesn't seem too crazy because this is one of the last lectures. We've got 3 more classes, only 3 more classes, 2 more real lectures, 1 fun lecture. But yeah, we should be able to finish this off next class. We're perfectly on track because the last lecture is so easy. It's just a relaxing lecture. But that's got it. We're going to head back over to the main screen. We should know what this output means. Let's go do the next question. Here we go. And we can come back and do more of the project, but that's the 2-sample T for the project. Make sure to look at the rubric because it walks through each thing. Josephine asks about the researcher of the glass question. Let's go do that researcher glass question. Getting it going up right here. And thank you so much. We're going to do as many questions as we can do. We're just knocking out these questions today. Let's go do the researcher glass question. Here we go. The researcher with a drinking glass question. Yeah. I think we'll circle back, Tiffany. And then we'll have done, I think, all of it. Oh my gosh. We'll have a video for each one. Let's go do the researcher glass question. Here we go. Wrong button. So this is, hey, it's a rainbow. This is the researcher glass question right here. And with the researcher glass question, what is the null hypothesis for the difference between a large and a small glass? That the difference would be what to 0? Review question. What would be the null hypothesis for the difference between the glasses? That'd be what to 0? Like if you give somebody a large glass and give someone a small glass, and then you say, let's look at how much liquid people pour in these glasses. The difference between them would be what according to the null? Equal. Null has the equal sign. So that means they are the same. The amount of liquid people put on average in a small glass or a large glass is the same. And then we're looking, did it change? Same. Great job right here. Great job, Josephine. Excellent work. Both Josephine, Kayla, and Tiffany, excellent work today. Now we're asking, is it the same? So whenever you're doing the alternative, so when you're doing the alternative, you have to go read the question, and it asks, did the glass size change the amount selected? Now, it's not saying people put more in a large glass or less in a large glass. It's asking, is there a difference between what they put in the glasses? So we need to then run this test by running the difference. And so is it different from, which would mean not equal. So this is the 2-tailed test. Is it not equal to? And we've got our TDF and our TD. We'll be using our just regular T. Great job, Kayla. Excellent work. Another 50 points, Kayla. Keep it up. I like the 50-point noise. It's my favorite noise. I should put it for the big one. Another 100 points. Why not? Lots of points. Okay, so now we need to find the T statistic and the P value. So to do this, I'm going to write the equations right here on the screen. Let's write the equations. For the t-test, we need the following. These will be given to you on the test, and this will be called the two-sample t-test. We do y bar 1 minus y bar 2. Remember, we're looking at the true difference, but we only know the sample. Yep, not today yet, but in Coleman, we can try to find that for you. All the videos are marked, so check that out. We have done Canvas content in 9 last week, I believe. S sub 1 squared over n sub 1 and plus s sub 2 squared over n sub 2. And this will be equal to a t with the degrees of freedom found by the degrees of freedom calculator. And I might disappear here for a second so I can finish off on the screen. So is the large glass group 1? I need to find out which glass is group 1. Mu1 is the population mean for the small glass. Okay, mu1 is small glass. Okay, cool. So please tell me if I make an error. We're making no errors today. So 5.29 minus 6.32. Those are the sample means. Square root. And S sub 1, 1.89 squared over N1, just N1, yep. There we go. Plus 2.92 squared over 22. A lot of math errors can happen right here. A lot of math errors. So we're going to find this. Let's go find our degrees of freedom really quickly. The degrees of freedom will need to be found via the degrees of freedom calculator. And make sure you put the numbers in right. We've got here our N1, which is 30. Our N2, which is 22. Our standard deviation 1, which is 1.89. Our standard deviation 2, which is 2.92. This means it is 33.58 degrees of freedom. Now we're going to go to our t-applet, and this tells us which t we are using. The t we are using is the following shape. Changing the degrees of freedom changes the shape of the t. More degrees of freedom, more normal. So now that we know which t, let's go and solve the equation to find out the actual t. The degrees of freedom are just notation telling us which t we are using. It was about 33.5 degrees of freedom. But that just tells you the shape of the t. It's not like we will multiply that. It just tells us this is a t with 33.5 degrees of freedom. It's the shape of it. So this has nothing to do with the answer other than showing us the shape of the t we are using. It'll look like this shape right here. And make sure to use the applets to find those answers. You will not have to do that on a test. We would tell you like t statistics, stuff like that with degrees of freedom. So we need to solve the answer right here. 1.89 squared divided by 30. Copy that. 2.29 squared divided by 22. And then add the two together. Square root that. 7.177, okay? 7.117. I'm going to double check my work because I have made mistakes on these. That's how you make mistakes right there. We are double checking to make sure we get it. Not going to make an error. Not going to happen. And then we add, and I think we're getting the same answer. It looks like we did it. Okay. Now that we got that and we square root it, a lot of times that's where the mistake occurs. We're going to take the difference up top, 5.29 minus 6.32, and divide that by the standard error. That's the difference. Divide by the standard error. And the t-score is negative 1.447. And that is the t. Negative 1.447. How many decimals do we need to round to? Here we'll hit close on all this. The t statistic rounded to 3 decimals, and that was rounded, I believe. I think I rounded it. Negative 1.447. I want to rewind the tape. Someone please tell me if I didn't round that correctly. I think I did. I'm like, oh, I don't want to get anything wrong. Now we're going to take that t statistic, plug it in here to the two-tailed, put in our t value, and there's the p value. It's 0.159. And does this say 4 decimals? It does. So I'm going to cheat right here, and I'm going to double check. Now, we should get this right. If you ever get one of these wrongs by the tiniest of decimals, please tell me, because I'm going to go over here to R. Got a bunch of R work up right now. And I'm going to look at the following. QT. Oh, it is that, Kayla. Awesome, Kayla. Thank you so much. Degrees of freedom, 33.57. Okay, it's infinity. We love that. That is, okay, yeah. So I want PT. And then we want to go here to the t-score of negative 1.447. I'm double checking our work right here. Times by 2. And there's a 2 on the end of this. Ooh, jump, you better. Oh. Ooh, it's giving me a slightly different answer right here. So that's, let me look at this. Negative 1.447. And there's the degrees. Let me get my degrees of freedom. Double check. I am triple checking my work. 33 point. There's the degrees of freedom right here. We're going to see what wiggle room it has. If you get one wrong by the smallest margins, tell me. 0.1572. So I'm going to take both answers and make sure it gives it both ways. Okay, so that's the exact. Ooh, I'm going to be super mad. So now this is the easier part. Yep, the 4 decimals. That's ridiculous. That's pretty crazy. It's higher. That's all that matters. So your conclusion, we right here would fail to reject the null. We do not reject. There does not provide evidence that to conclude that the mean for the smaller glass is blank. The mean for the larger glass is different from. I'm so worried about that p-value. I almost feel like I should have gone with what the applet shows. Do not reject the null. Do not provide evidence. You better not. Woo! Better not. Not today, my Pearson. Not today. Yeah, please tell me if this p-value is off for you. The exactness of this one, please tell me if you get that wrong. Let me see right here. Because the exactness of this one is pretty ridiculous. I'm glad I went over here to R. Not today, we got it right, but this would not be expected of you. And that drives me crazy. That it's like you would have to use this right here to get it exactly how it wants it. Because this looks like it's rounding it up right here. Because, oh, wait. Oh, you can't. Oh, but you see, this would round up. So you see, you would need to round it in this. And let's see if this gives the right answer now. That one doesn't accept that many decimals. So let's see if we had put that in. Would it have accepted it? Because we should have rounded up then. Nope. Would have said nope. So please tell me if you get this one wrong because of the wiggle room on it. I think this version can come out with ones that are wrong. It's ridiculous, but this is basically the p-value right here. We didn't get it wrong, but I like I said, I was going to like double check my values, which I don't expect you to go into R and do that. So I wish it didn't ask it for 4 decimals because the last decimal is just like you're asking for tens thousandths. So a little bit ridiculous right there. Please email me if you get it wrong by the smallest amount. You can't see yours yet because you need, well, when you finish it, let me know. And I might even eventually remove that question because the 4th decimal is where the problem's at. The 4th decimal is like, you really have to have a very exact t statistic. And yeah, it's just, we got it right though. Not today, my Pearson, not today. Great work. Gosh, don't like that one right there with the exactness of it. That's a little too extreme. Next question we have on the docket. I'm sorry, everybody. Someone's like, oh, come on. Why? It's my Pearson. It's why. Next question was, I'm going back to the start. Can we go over chapter 16? Kylie asked, each of the situations define a parameter and write the null. Chapter 16, parameter and write the null. Chapter 16 is coming up due real soon, right? Chapter 16 quiz is due tomorrow. Oh my gosh. Whew. We got done with chapter 16 today. So if you're in today's afternoon class, get ready to finish off chapter 16 right here. Let's go to replace questions. And let's go check it out. Chapter 16. In each of these situations, in each of these situations, write out the null. We got it right here. Here we go. Writing out the null and alternative. Let's go check it out. It's just the null. It's just the null. Let's go write the null hypothesis. Okay. So there's only 2 choices right here. What are the only 2 choices for the parameter right here that makes sense? Like, if you're looking at this question right here, it says like, let something. So there's only one of these you'll pick. Like between two of these. Like two of these make sense, two of these don't make sense. Which of these makes sense right here? So if you can narrow this down to two choices every time, you're good. And then you have to pick between them. So which of these choices right here make any sort of sense? P and mu, exactly. So P, great job, Kayla, right there. P is when it's proportions, and then mu is when we're talking about quantitative data. So it can only be P or mu. For the project, how might we go about shortening interpretation off fundamental? You can have me look it over. You can send it to me. Just want to think about like talking to someone in general. Just think about ways to like just talk to someone. That's the art of statistics. So P is when we do proportions, which means it's categorical. And so how do you know if they're, that's Kylie. That's the question, right? That's the question. So we're asking, let something equal the something of wins. So are we dealing with quantitative or are we dealing with proportions? So I want you to go up to a slot machine. I want you to pull the handle and see if you won. Is that a quantitative response or is that a categorical response? You're going to walk up to the slot machine. You're going to pull the machine and you're going to see if you won or you did not win. Is that quantities or is that categories? What do you think right there? C or Q for you go up to a slot machine and you pull it and you see if you win. So what do you think? Is that quantitative or categorical? So you're going to go up to a slot machine and say, am I going to win from this? Let me pull the handle right here and see if I win. Yep, to win or not is a category, which would mean the proportion of time you win. So this is the proportion of time you win. So you want to understand if the proportion of time you win is equal to, and so we'll go here to proportions. So we're dealing with proportion of time you win. So every one you see right here has to be P. If it's P here, it'll be P here, it'll be P here. So it has to stay the same. The null always has the equal sign. Let's just kind of go through here. That's probably the easiest thing to do for any of these is the null has the equal sign. Just we know that. Kylie, great work right there. And we want to see if the proportions, it says, is the proportion of slot machines. So a casino wants to know if their slot machine really delivers 3 in 100 wins. So what would be the alternative right here? Like think about it is either that the slot machine gives you 3 in 100 wins, like 3% of the time you win, or it is not the case. So which one of those? The first, the second, the third, or the fourth? I don't like the way they even have those written right there because there's only one choice right there. What would be and so what would be it? The first, second, third, or fourth? Does not equals exactly because either it is 3% wins or it is not 3% wins. Last year's customers spent on average this much money on a company's website based on the sample purchases this year. The company wants to know if it's increased. So now this is how much they spent on average. So maybe what do you think right here? What do you think? Because that's how much they spent on average. Like they go to our website and then a customer spends a certain amount. Does that sound like categories or quantities? This is how much the customer spent on average. So does that sound like categories or quantities? This is how much they spent on average. Kylie, this is a great review right here. A lot of people are like, well, how would I know the difference between these? Kylie, you're seeing it. This is the practice. It's mu, and that's going to be mean. So if it's mu, it's mean. And these are all mu then. So it'll still be mu for all of these. And the company wants to know if it's, and then Kayla's got the alternative. The company wants to know if it's increased. So the alternative right here would be if it's increased right here. So we're looking for evidence of an increase to the sales. A pharmaceutical company wants to know if their new drug has a cure rate lower than 40%. So we'd go up to somebody and say, did this cure them? Did this not cure them? Categories or quantities? We'd have to, when we collect data, we'd say, like, okay, this person was cured. This person was not cured. This person was cured from the drug. This person was not cured. Because you might say 40%, that's a quantity, right? But when we collect the data, this is the what of people who are cured. Yeah, no, Kylie, 100 points. Like, once you see, you're like, I got it. You're like, I get it. It's good practice. So this one right here is whether people are cured or not. So it's definitely what? So even though this looks like, oh, that's a quantity. That's the percent of people who are cured. Well, wait, percent means it's proportions. So were you cured or not is the proportion of people who are cured. And then the proportion of people who are cured is probably equal to 40%. That's the null hypothesis. And we want to know if their new drug has a cure rate lower than. So the proportion of people who are cured are less than. A bank wants to know if the percent of customers, what do you think? We're looking at the website, has decreased from 20%. So decrease is the claim. And then if we're talking about the percent of customers who use a website, what do you think right here? Percent of customers using a website just gives it away. Oh, careful. The question would be, do they use the website? Oh, wait. Oh, wait. So the question is, do they use the website? So you'd have to collect this person used the website, this person did not use the website. I tricked you. No. Percent sounds a lot like proportion. Proportion. So even though it's a number, yeah, don't worry, 100 points. This is the practice. You have to think about how the data is collected. If you get the percent of people who use a website, you'd have to ask everybody, did you use the website? Does that make sense? Like, if you go up to someone and say, did you use the website? You're asking a categorical question, and then you could find out the percent of people who use the website. It's like, imagine we ask someone, do you own a dog? We can find the percent of people who own a dog, but the question is answered yes, no. So percents come from categorical data. So even though percent's like, well, isn't that a quantity? It comes from the percent that conform to a group. So you have the yes, I use the website group, the no, don't use the website group, and the percent that conform to that group would be the proportion. So this will be P here again. Watch me get one wrong. Not today, my Pearson. Not today. I'm going to get one wrong because I'm going to click like a P hat or something like that. No, not today, my Pearson. But really good review right here of when to use nulls and alternatives and how to write them, and to switch between quantitative and categorical. Ooh, percent. Oh no! Sorry, I didn't mean to trick everybody right there. Today, my brain's going full power. Today, last week, I just think last week I was like half asleep all week. I got some good sleep this week and got a little bit caught up. It's the way to go. We're all catching up on our sleep. Let's hop back to the main screen. Let's do this. Excellent work. Good practice. And so the next question, we'll do some more chapter 16. The next question, we'll do another project thing because I might even take the project portions, cut them out of the videos. Next question is from company being sued. Kylie has the next one. Company being sued, and grab those questions again. Company being sued. Company is being sued for discrimination. This one's got some power analysis in it. Found it right away. Here we go. I love it. Thank you, Kayla, so much for being here. Everyone who's here, just hanging out, going through work. It really is a lot of fun. Like, I'm so glad I always have people here in office hours, like hanging out, doing some work, because it's more fun to have this conversation. It's like someone's actually here, and it's like just type something, we read it. Ooh. A company is being sued for discrimination. Dun dun dun. And it's not good. Because only 18% of the newly hired candidates were minorities, when 35% of the applicants were minorities. Is this strong evidence that the company's hiring practices are discriminatory? What? Oh, I might like literally cut them out into their own videos. It's called splicing your videos. Some people, there's a YouTube term for it. So I might literally make a playlist, because if I do the last one today, I could cut them later tonight and put them in their own videos and then post it as like a playlist so people could find it really easily. So be good stuff. I don't even know. Okay, so when you think about this right here, we wouldn't really write the null hypothesis quite such a way, but we could. The null hypothesis is the company is innocent. And the alternative that they're trying to show is guilty, and discrimination would mean too few hired. So the company, oops, I'm blocking everything. The company is innocent until we show evidence of guilt. No prompt. Make it look like a report. Good question, Alexander, right there. Make it look like a full report and everything. Oh, you thought I'd like delete out the portions? No. Like, I've ever watched that before Brian removes it. No, I'd take it and put it in its own video, but it would still exist in this portion too. It would just get its own separate video. So when we think about this right here, we have that the company is innocent is the null hypothesis, because that's how things should start out. And then we have here that the company is guilty, which means they hired too few candidates. So is this a one-tailed or a two-tailed test? If you think about this, they're trying to show evidence of too few being hired. So it's definitely going to be a one-tailed test, because they wouldn't be sued if too many. I mean, they could. I mean, you don't know. This is craziness. This is a one-tailed test because the company wouldn't be sued. They just write this all weird. It's they're trying to find evidence of, so it'll be one-tailed because they're looking for evidence of too few people being hired. So it should say something like, how would the prosecution frame this? And the prosecution is going to frame it as a one-tailed test to show evidence that the true proportion, that they hired too few. Like, we have evidence here that, this is not by random chance that they hired this many. You would expect them to hire this many. Yeah, and so because of the idea of too few, they're trying to show like a less than test. So they're trying to show that less than what we would have expected is hired. Yeah, exactly. That's a little tricky right there. It's a good one, a little tricky. Let's undo the last two steps. Boop, boop. In context, what is a type 1 error? In a type 1 error, the null is what? I'm not going to block the null right there. In a type 1 error, the null is what? I'll show you here in a second. We got to do our practice. You got a cheat sheet right in front of you right now. In a type 1 error, the null is what? In a type 1 error, the null is what? The null is true. So just think about this. You just said it's true that the company is innocent. It is true that the company is innocent. This is true. But we're going to reject that. So we're going to say, nope, I reject the truth. We don't know it's the truth. Like you say, well, why would you reject the truth? Well, you don't know that. The null is true and we reject it. So now we're going to say there's evidence of them being guilty. Just always repeat it. In a type 1, the null is true and we reject it. It is true that the company is innocent, but I'm going to reject that and show evidence of guilt. It's just the way the court case goes. So the type 1 error is deciding that the company is discriminating when in fact it is not. So there's only really two errors on here, because either they'll decide that it's not discriminating when it is, which would be type 2 coming up here in a second. But good way to draw it out right here and to make sure we can see that in a type 1 error, it is decided that the company is discriminating because we reject the null and have evidence of guilt when in fact the company was not. So good stuff right there. Not good, but errors. In context, what is a type 2? In a type 2, and if you're watching this video, I want you to practice this. In a type 2, do you see the 2? The null is false. Kale's got right there for 100 points, and we fail to reject it. Now listen, we said the null is false. That's an F, and we fail to reject it. You can just repeat it. In a type 1, the null is true, and we reject it. In a type 2, the null is false, and we fail to reject it. Easiest way to memorize it, just remember like this. It is false, and we fail to reject it. So the null was false. So what does that mean for us? This is a false statement. It is false that the company is innocent. Well, that means it's true that the company is guilty. But we are going to fail to reject the null, so we're going to hang on to it. So, but it's true that the company is guilty. It is false that they're innocent. The null is false in a type 2, but we're not going to reject it. We're going to fail to reject it. So in a type 2 error, the company, it is decided the company is not discriminating when in fact it is. Make sure I don't make any errors here. It is decided the company is not discriminating because we're failing to reject the false null when it actually is, because null is false. Exactly. And Kayla, you said it a better way than they're saying it. We believe they are innocent when they're actually not. Like the company was actually discriminating. Like the guilty is true. So the null is false. So the guilty is true. And so the company was actually discriminating. Yeah, that's, yep. Nope, bad stuff. And so explain what the power of a test means. So when you think about the power is the ability to correctly reject the false null. We have it over here in the chapter 16 notes. Power is the ability to correctly reject the false null. So if the company is discriminating, so if the null is false, the company is discriminating, power would be the probability that we find that the company is discriminating. Remember, the null is that the company is not discriminating. So if the null is false, then the power of the test is the probability of correctly determining the company is discriminating. Because we want to be able to find evidence for the alternative if it exists. And a powerful test would be able to think about this. A powerful test will figure out that the company is discriminating if they actually are. So we want a powerful test right here that can figure out if the company is actually discriminating. And a powerful test would do that. Oh, let me repeat again. I'll go back to the slides. Thank you, Kayla. These are complex topics. So when you look at power right here, power is basically not making a what? Just look at the equation for power. And power is not making a what? Power, if you think it says the ability to correctly reject the false null, but power mathematically is not making a which error though. You are right in error, but which error? So power is everything but making a what error? Power is everything but making a what error? Type 2, because beta is type 2. If you remember back, we were talking about this today in class. If you haven't been in class today, we'll talk about type 1, type 2 with alpha, beta. But power is not making a type 2 error right here, which is beta. So we have right here, a powerful test will not make a type 2 error. A type 2 error would be failing to find that the company is guilty. Because remember, in a type 2 error, the null is false, but we fail to reject it. We hang on to it. So if we don't make a type 2 error, we would then what? If we're not making type 2 errors, then we would be able to find that the company is guilty when it is. Does that make sense? Because a type 2 error is failing to find the guilt of a company. So by not making type 2 errors, we will reject the null when we should. Does that make sense? It might be a better way of phrasing it. Like, you can memorize the term power is the ability to correctly reject the false null, but correct, if we're not making type 2 errors, then we're not failing to reject the false null. We are correctly rejecting the false null. We should be able to reject the null when we can. So a powerful test would not make type 2s. It would not fail to reject the false null. It would reject the false null when it should. That's what a powerful test would do. I hope that makes more sense. It's a complex topic, but we don't want to make type 2 errors. Power is the ability to correctly reject the false null. And so if the null is false, that means the company's discriminating. A powerful test could correctly determine of discrimination. Does that make sense? Oh, you bet, Casey. You get. We can do that here next. I think so. Here, we'll finish this off, then we'll do Casey's question. The hypothesis is being tested at a 10% significance level instead of a 5. How will this affect? That's such a weird way of wording it. They're doing it at 10% instead of 5. So how will that determine the power of a test? So what did they do to their alpha? This is so weird. They're saying their alpha is at 10% instead of 5. So alpha has gone up. Alpha went up. It's being tested. So the test, I just want to make sure this one's got me on the wording. The hypothesis is tested at the 10% level instead of the 5. So what does this mean that alpha is higher? Because the significance level is alpha. When it says significance, this means alpha. And we're doing it at the 10%, not the 5. So how does this impact power? What happens to the power of a test if we increase alpha? Good notes right here on the screen. Increasing alpha, which is what they're talking about. They said alpha is higher. Yeah, Kylie, you bet. I think we'll do that next because your questions are higher. So what happens to alpha right here? If alpha goes up, beta goes down, and power does what? They raised it so power will go up. Since the alpha is higher, power will go up. So we can say right here, the power of the test will increase because the level of significance has increased. And that's exactly what we're seeing in these notes right here, is that the alpha level has gone up, so beta would go down, but power would go up because beta and power are the complements of each other. So because alpha is higher, then power will also be higher. The lawsuit is based on 46 employees. Is the power of the test higher than, lower than, or is it the same if it were based on 125? So 46 is a what sample size to 125? 46 is a what sample size to 125? 46, and we're talking about sample size now, 46, and we'd have to flip this whole thing, is a what sample size to 125? 46 is a what sample size to 125? Oh, but no, wait, so it's saying, let me double check. The lawsuit is based on 46. Is the power of the test higher than or lower than the same if it were based on 125? So it's saying it's 46. How does this compare to 125? Yeah, they word it such a weird way. They should say, for an N of 46, how does the power compare to a sample of 125? And so the sample size is lower right here. The power of the test is lower because the sample size decreases. Wait, what? Did we not click something? I think we didn't click something. Oh, context of a type 1 error. Ooh, let's double check. Type 2 error is the company is decided the company is discriminating when it's not. So a type 1 error, the null is true, and we reject it. So deciding the company is discriminating when in fact it is not. Whew. Scary last few ones on the end there, making sure we're doing the directions right. but make sure to review the notes. The last question isn't going from exactly, yeah, it's weird the way they ask it, because they're saying it's based on 46, so that would be a lower power. Does that, so here, let me rephrase it. It says, right now we have 46 people it's based on. Is that less or more power than 125? Right now it's based on 46 people. Is that less or more power than 125? Does that make sense, Kayla? Right now it's based on 46. Is that less or more power than 125? And the power test would be lower for 46. So yeah, it's they ask in such a weird way. They should have saw me the first semester doing these. But yeah, that's a bit weird. It just says, does 46 have less or more power than 125? And the answer is 46 has less power because sample size is smaller, and smaller sample size would go to less power. Higher sample size, more power. Good stuff right there. Let's hop over to Kylie's questions. Let's do this right here. Some fun music. Hopping in the main screen. Whew, got to read every question carefully. Last week I was just like... Kylie's question. Kylie, wait. Kylie, which questions did you have? You might want to copy paste them real quick. I'm trying to find Kylie's questions. Can you answer the two other questions that I had that are way up there? Kylie, if you can copy paste them real quick again. I've been trying to go through everything in order. I might have actually, like, chapter 6 about a company being sued. We just did company being sued. Also, chapter 16 about the mistakes that can be made with the hypothesis test. We'll do the mistakes that can be made, and I think we're going to do a different one here. The mistakes... Well, let me go back up. No! The mistakes that can be made with hypothesis test, chapter 16. Mistakes that can be made with hypothesis test, chapter 16. We're going to do some 2 sample 2 team. The mistakes... Oh, here we go. Here we go. Here we go, some mistakes. Let's do some multiple choice stuff here. Multiple choice type stuff on chapter 16. Let's go check it out. Which of the followings are mistakes that can be made with a hypothesis test? The null is true and we reject it. That sounds a lot like a what? It says the null is true and we reject it. What does that sound like to you? If I say the null is true and we reject it, sounds a lot like that's a what? Yep, I think so, Tiffany, because that'll be really great. We'll get that. We will definitely do that today. Tiffany, I 100% agree. No, I'm gonna do that here. Definitely, maybe next. That is a type 1. So here, we'll do that next. So this is a type 1. The null is true and we reject it. Now, do you see another error right here? Like, which of these is another error right here? So if the null is true and we reject it, that's a type 1. In a type 1, the null is true and we reject it. In a type 2, the null is what and we what it. And so do we also see that on the screen right here? In a type 2, the null is what and we what it. Do we also see that? So we know 1 is a type 1 error. So a type 1 error is when the null is true and we reject it. Oh, yeah, I think we can. We should have just enough time. Probably, I think I just enough time. And then a type 2 is where? So practice. In a type 2, the null is false and we fail to reject. So that's which number on here. So we should know which ones are the 2 types of errors. The null is true and we reject it. It's a type 1. The null is false and we fail to reject it. It's a type 2. And we can memorize it just right there. And that means answers 1 and answers 3 should be the errors. And there we go. And then I think you're asking about what is the name for the difference between the value in the null hypothesis and the true parameter? So this is like LeBron and I when we're playing basketball right here, the actual difference for us. What is the difference between what we hypothesized and the actual, what is this called? A, B, C, or D? So the actual difference between LeBron and Brian, that's effect size right there. That's how big is the effect like between LeBron and Brian? Like well, they're the same, but there's a big difference between us. That's an effect size right there. We're going to do just a multiple choice right here. Which of the following is the correct interpretation of a small p-value? A small p-value would tell us that something is unlikely. So definitely rare event right here. If the p-value is small, that tells us the thing was unlikely. Today in class, we did an example with someone running a mile and taking like 8 minutes. And that would be unlikely if they were a 4-minute mile runner. So what we would witness was rare, given the null is true. So we should reject the null. Wait. So it's not. What we instated, we witnessed and they are a rare event. So we should fail to reject what? That doesn't count. It should just say high p-value. The p-value is high, not small. Ooh, how dare you, my person? How dare you? Brian, I definitely can't English. 100 points right there. If the p-value is smaller than the level of significance, what should we do? Pretty quick and easy right here. If the p-value is low, do what? It's saying the p-value is lower than alpha. Level of significance is your alpha. So p-value lower than alpha. Nice and easy right here. Just p-value lower than alpha. P-value lower than alpha. What should we do? P-value lower than alpha. P-value is lower than alpha. Reject that. Null. Not going to make any errors. What is the name for the threshold where we reject? P-value is lower than this. We reject. Review right there. Alpha. So when the p-value is lower than our alpha, we reject. What is the probability that a test correctly rejects the false null? So Kayla, good. Wouldn't you love it if, man, you'd be like, yes. I know. Not off Alpha Sprout. So what is the probability to correctly reject the false null hypothesis? And so you can see the different things on here. Significance is your alpha level. P-value is the probability of our results or results from our stream given the null is true. Type 2 is when we fail to reject the false null. That's what your husband said. The power of the test is the ability to correctly reject the false null. What type of error is made when a false null is not rejected? What type of error is made when a false null is not rejected or failed to rejected right here? The type of error that is made when we have a false null and we fail to reject it is a type 2. So really good practice. These multiple choices are excellent. I'd love it if they're on the test. What type of error is made when the true null is rejected? Type 1, the null is true and we reject it. So that is a type 1 right there. Type 3 and 4 do not exist. And there we go. We'll come back here. I was bragging. Let's do some t-tests, and then Kayla, we will put in, we might speed run that last question, but let's hop back to the main screen. Some good stuff right there. Kylie, thank you so much for all those questions. Kylie, thank you. Kylie put it on the Discord. Some extra people might have joined in. Thank you for asking about that on the Discord, Kylie, and I took a moment to make today's video, but thank you so much. Probably we got a few more people watching today and knowing about the office hours by you asking about it, and thank you so much. Let's go talk about that t-test. Okay. Getting the things pulled up right here to talk about the t-test. Okay, let's go talk about the t-test on the project. So we're going to do a t-test here. I'm going to use different data, but the number one thing you can do to make sure you ace the t-test is to look at the instructions right here, the rubric. Literally tells you how the graders are going to be grading you. The first portion for the t-test will be creation of a proper histogram with summary statistics and inclusion of proper shape, center, and spread. So let's go ahead and remember we need to do something relevant to our company. These are other portions of the project you'll work on, but you'll need to outline your company at the start here. Please read over the rubric and see what your graders will be grading you on. This is how you're going to be grading. They literally click these buttons when they're grading you. So let's go ahead and get this one sample T created right here. And to do that, we need to go over to Jump. So have a data set you want to use open. The data sets are found on the project page. I just want to show that real briefly again right here. That on the project page, go scroll all the way up right here, you will see the data sets you'll be using right here with kind of instructions of what the data sets have in them. So let's go back to our one sample T and actually start creating it right here. So to create a histogram, we go here to Analyze Distribution. Analyze Distribution. This is to analyze univariate data, which means just one variable. Now, I'm going to analyze, let's go and analyze the high school GPA. So I analyzed this for the two-variate. See, everyone, I don't want everyone to do the same thing I'm doing. I'm doing a tutoring center. I'm doing a Stats 1 tutoring center. Everyone don't steal that idea. No. Unique stuff really helps with looking for issues of plagiarism on projects. If everyone does a tutoring center. No, it is, oh, someone heard that. No. Just everyone's like, I'm gonna do a tutoring center too. Well, you just need to do your own work here, though. You need to do your own work. Okay. So let's go in here. You might be using a different data set too, like the PIMA data set and all that different stuff, looking at diabetes and glucose levels and all that good stuff. So not good stuff, but other data stuff. So let's go here and put the variable in. It needs to be blue, which means it's quantitative. I can't highlight that enough. That this right here is blue, which means it's quantitative, and we will see here a histogram. Oh, pretty interesting. Pretty interesting. I'm going to go here to the top right arrow. I'm going to click stack, which will put it in, people are like dibs. And so we're going to put it in horizontal layout with the stack button. I'm going to make it a little bit longer right here. Just there we go. There we go. Look at that. Make it nice and neat. And so I would add this in. These are just extra accoutrements, little salt bay. And we're going to go here to the second red arrow. And we're going to go to histogram options. Count axis. You don't need these, but it'll really help make it look nice. There's a count axis right there. Go to the second one again and go to histogram options. Go to, where's the color? Did they move it? Display options? Ooh, did they move my histogram color? Oh, histogram color, there it is. I was like, they better not have moved it. I'm gonna go here to a nice blue today. That's nice ocean blue. And I think that's basically got it. Looking good. What do you notice about this? This is definitely what, when we talk about the shape, it's definitely this. This 100%, you can't describe it any other way than unimodal. Unimodal means it has one mode. I see a little bit of left skew, especially since the mean is lower than the median. So the mean being lower than the median, little bit of left skew. The mean is 3.8, and it's actually the center of that diamond right there. And the median is 3.85. It looks kind of normal, right? I mean, there's some outliers. It almost, I would say, if like I'm talking about this, I'd say the histogram looks somewhat normal, but there's a tiny bit of left skew with some extreme outliers on the low end with someone with a 1.8 GPA and other GPAs in the mid to low twos. There are also some outliers on the high side that are not as extreme. The highest person had a GPA of a 5.0. So just think about how you would describe this with the shape. The best center for this distribution, since it's mostly normal, I'm going to say it's mostly normal. And since it's mostly normal, I think the best center for it is going to be the mean of 3.8, which is the average individual, and the standard deviation of 0.4, which shows us the spread of the distribution. That whole thing right here is what we're doing. We're going to take a picture of this and include it. But we just talked through the portion right here where it says, creation of histogram with summary statistics and inclusion of shape, center, and spread. All components are displayed and interpretation of the visualization is correct. So if you miss your interpretations, you could lose points, or if you don't have your output, you could lose points. But I talked through the shape, how I thought it was unimodal, how I thought it had a little bit of skew, how I mentioned the outliers. That's the shape. Then I talked through the center by talking about the mean, the average person had a GPA of this. Then I talked about the spread by saying that there is a spread of the standard deviation of this, telling us how far the values are spread out from the mean. So make sure to talk about the shape, the center, and the spread, and include like at least a sentence for each part of those. Next, we need to build a confidence interval for the mean is provided along with the interpretation. And what percent are we building? Do we get to build whatever percent confidence we want? Because frankly, life is easier than you think if that's the case. Has a count axis. So please note, Brian is corrected right here. It does say to put a count axis on it. So make sure to do that. Make sure to put a count axis on it. It does want a count axis. I don't think it's the end of the world, and they shouldn't take off a lot of points if you don't include it, but you do need that count axis. I want to point that out. So please make sure it's talking about the following right here, the count axis. It does want that. So we get to choose it. Well, guess what? We've already got a 95% confidence interval right there. So if you already want to make your 95% confidence interval, there it is right there. 95% confidence interval is already displayed for us on the screen. So we can literally look at this interval right here. Let's zoom in on it and talk about we are 95% confident. So I am 95% confident the true mean GPA of individuals is contained in the interval. I'm 95% confident the true mean of GPA of individuals is contained in the interval 3.7818 right there to 3.835. Now, if you don't want to do 95% confidence, you could go over here and go to confidence interval and select any sort of interval you want with other, or you could use one of the ones like 90, 95, or 99. So you could be even more confident and include this output right here, going from a GPA of 3.77 to 3.84. The word distributions, oh, you don't include this. Yeah, no worries. Great question, Kaylee, right there. I didn't yours. That's quite all right. Yeah, you wouldn't need to include that. Your screenshot for the first screenshot should include this right here. That would be your first screenshot. And then your second screenshot. Thank you so much.
Wow.
Oh, it doesn't matter. Gosh, I forgot where my buttons are at. And your second screenshot's going to look like this. when you talk about the confidence interval right there, the second screenshot is going to be that area. And now the confidence interval, when we interpret this confidence interval, when we interpret it, I am. And it literally, I think, shows you, we kind of give it away on the project, right? No, it's talking about the interpretations. Create a confidence interval of your choosing. Include a separate picture. No, they should. If you don't include the distributions thing, that'd be crazy. Please tell me if points are taken off like that. That'd be ridiculous. Include a separate picture of the confidence interval interpret to the reader of the confidence interval. So we always say, I am blank % confident that the true blank is contained in the interval blank to blank. Where'd it go? I am blank % confident that the true is contained in the interval blank to blank. The mistake I see on interpreting confidence intervals is usually the second part. A lot of people just say true proportion. But is this true proportion right here? And we'll go to the other interval I made. Is this true proportion right here? Would I interpret this as the true proportion? We'll take a look. It kind of gives it away. You could use the 95%. I would just take a separate screenshot of it. You could use the 95. I'd probably use this, but they should allow you to use the 95%. So Kale, you're on the right track, and then make sure to say like the true mean of high school GPA. So this is the true mean high school GPA for the students I'm trying to understand. Does that make sense? I am 95% confident the true mean high school GPA of students I am trying to, or 99, I should say. I am 99% confident that the true mean high school GPA, and there's mean, and we're trying to estimate the true mean high school GPA of these students we're trying to understand, is contained in the interval, and then you have the lower bound right here to the upper bound right here. And that's got it. That's the I am 99% confident. Context, exactly. All data needs context. That the true mean GPA of these students we're trying to understand is contained in the interval 3.77 to 3.84. Finally, include a value that is hypothesized that your company wants to test in a does not equals hypothesis test. Explain the decision your company makes about the hypothesis value and how they arrive at their conclusion by using the confidence interval. So my company is interested in testing the GPA of 3.9. And we consider that to be a very high GPA. And if students have a high school GPA greater than, like if 3.9 is the true value of the students' GPAs, we probably shouldn't try to market to these students because that's a very high GPA. So the null hypothesis would be, and just to write this out, that the true mean GPA is equal to 3.9. The alternative would be that the true mean GPA is not equal to 3.9. So when I look at this interval right here, what about this interval over here could be done to see if we could test 3.9? So how could we test 3.9 right here? How could we look to see if 3.9 is a possible truth? To be like, is 3.9 the true value of their GPA? And that means mu naught is equal to 3.9. Is 3.9 in the interval? Oh, is it CF? You got it right there. Sorry, CF. I'd use the second picture. I like a separate screenshot. That's my pro tip advice. Use a second screenshot. So we would see. I just made up 3.9. So the hypothesized value can be anything you want. My company considers 3.9 to be a very high GPA, and gosh, I feel like everyone's gonna do the exact same thing. My company feels like 3.9 is a very high GPA, and that we are not going to market to them if they have a 3.9, if the average GPA is a 3.9 at this school. And we're one of those backpack companies or one of those that is trying to go around and get people to use their services. And we're if the GPA is this high, we probably shouldn't market. So we're testing to see if there is an average GPA of 3.9, and we would reject it because 3.9 is not in the interval. If you look at the interval, 3.9 is outside the interval. And then we're just saying, is 3.9 the truth? And we have evidence that 3.9 is not the truth because it's outside the interval. So we would say we have evidence that 3.9, the true mean GPA is not 3.9. Does that make sense? We would reject the value of 3.9 because it's outside the interval. and we have evidence that 3.9 is not the truth. And so make sure to explain what value your company is testing. You'll just hypothesize any value, and then that value will just be what your company tests. And then you'll see if it's in the interval. And if it's in the interval, you would not reject it. And if it's outside the interval, you would reject it. So good stuff right there. That's got it. We can look at the rubric right here. The t-test right here. Explain how the test and interval come to the same conclusion. Explain well to the reader. One detail about the results is not well explained. So you're just going to walk through and talk about what I gave right there. Yeah. And you can see the other interpretations of confidence interval. The confidence interval for a chosen level of confidence for the mean is provided. The interpretation of the confidence interval is complete, including level of confidence, population parameter, and upper and lower limits. Just make up a value of the null. Exactly. The null value is just created, and that's what we hypothesized to be true for the last part. So hopefully this makes a lot more sense. How are people doing on this? Definitely come back and review, but make sure when you go through, like, you explain well to the reader. Like, don't be short on your words here. Try to give as much verbose explanations as you can. We're going to go do another example. We're going to do Kayla's question. Thank you so much, Kayla, right here. But let me know if you have questions. We'll probably do more of this week. I might splice these into new videos, but we'll check that out. Let's hop back to the main screen. I'm going to send out the announcement to the afternoon class real quick, 2 seconds. And that way we have enough time to do the last question right here. My gosh, time flies. Last full week of school right here. And everyone's like, I was like, taking class, I was like, well, Monday, Tuesday, Wednesday next week. And everyone's like, no, we don't have Wednesday. I might even have a classmate for Wednesday next week, apparently. No, did I not? Oh, I was smart and I didn't even do that when I made, gosh. I cannot believe it. I just watched the times countdown. Okay, let me send the announcement to class real quick. Class in 22 minutes. See you soon. Big bonus. I mean it. 100 points. Click here. Okay, got that going. And send. Let's go check out this last question. Did you say that you did the what? Yep. Awesome. Real quick, which videos covered chapter 15? Oh, no worries. Probably early last week, Bradley. Email me if you can't find it, and we'll find that for you. Each video is marked. After you come back, you can click any of the office hours videos, and they all go into an office hours playlist. It's good to see you, Jacob. But check it out, Bradley. If you can't find it, let me know. But we do a lot of, it'll be marked in the video description, everything we've covered in that video. So you'll see like Stat 201 chapter 15 in one of the videos. And if you can't find it, email me and I'll find them for you. Let's go do the last question of the day. Chapter 17, traditional, non-traditional, right? Chapter 17, traditional, non-traditional learning methods. And excellent work, everybody. Chapter 17, traditional, non-traditional learning methods. And let's go check this out. We almost got it. Oh, found it. Here we are with the chapter 17, traditional, non-traditional learning methods. And let's go check it out. Kayla, you are a rock star. Truly, you reached that level and you truly are. Thank you, Kayla, so much. Let's go check this out. Chapter 17, traditional, non-traditional learning methods. So the decimals make the first part of this question more difficult. But I want you to think about this. I want you to tell me how long an interval is from -2 to 4. Just tell me from -2 to 4, how long is that interval? I know it's not what it says. -2 to 4, how long is that interval? I'll draw it out so we can see it. And I want you to tell me how long an interval is from -2 to 4. So if you went from -2 to 4, how long is this interval right here? You're close. So think upper minus lower. Upper minus lower. So how long is that interval right there? And then we're just going to throw on the decimals. So this interval is how long right here? Well, it's how far away is 4 from -2? So how far away is 4 from -2? So it'd be like 4 and -2 are how far away from each other? Just the first question right here. How far away are those numbers from each other? I've got the mathematics written up there up top. So the distance those numbers are away. I'll give you a help. Hint right here. That's the distance of 2. And that's the distance of 4. 6, exactly. So those are 6 away. So let's change the numbers to our numbers here. And so all we're going to do is just use the same mathematics. And now we have 1.708. And, well, the 4 goes here. 4.108. And minus minus. So how far are those numbers away? How far are those numbers away? How far are those numbers away from each other? So we're doing the same mathematics, right? So it's about 6. Not quite. But does this make sense? We're doing the same mathematics here to find how far those numbers are away. 4.108, and then minus minus means add. Does that make sense, Kayla? So it's we use similar numbers to like be like understanding the concept. But remember, since you're doing minus minus, it has to be plus, because it's on the other end of the 0. So no, don't worry. You've seen me make mistakes. Don't worry about it. So now the question becomes, what is the margin of error? If this is the whole length of the interval, Kayla, so the interval itself goes from here to here, the margin of error would look like this. How do we find a margin of error on this, Kayla? What do we do to the whole length of the interval, which is this? That's the length of the interval. You got it? Half the length of the interval. Does that make sense? That would be the margin of error, is half the length of the interval. So we found out how far the numbers are away from each other, and then we take half of that. So now we have the margin of error. And that's the margin of error. So excellent work, Kayla. 100 points. Practice. Once you get it down, it's more like, okay, half the length of the interval is the margin of error. And you got it. If a 95% confidence interval is created, would the margin of error be larger or smaller? So this is 90, 95. So would it be larger or smaller? It's going to go from 90 to 95. So what would happen right here? 90 to 95, the margin of error would be what? 90 to 95. So 68. 90, 95. It's not those numbers, but 68, 95, 99.7. Well, from 90 to 95, it'd be larger. And so it's talking about the critical value, which is a t-score we're using here. This would be a larger t-score. And you can see this if you go to a t-applet. It's talking about, we don't have a t-applet up. It's talking about the t used to create the interval. And the margin of error would increase also because it's literally going to get wider, because the critical value is increasing. So this is talking about, nice job, Kayla, right there. It's talking about this t-score we would use right here, where if we went from a 90% confidence interval to a 95, this t-score, which I'm probably blocking, that t-score down here gets larger, going from a 90 to 95. That's the critical value it's talking about. And then the margin of error would get bigger. So that all coincides. Explain what the calculated interval means in context. With 90% confidence, so we see that the interval here is negative down here with the 1.7. So the traditional might have a higher average by that amount. Students in traditional math score classes will score on average between this points, that needs to be higher. So this could be, okay, here we go. 90% confidence, students in non-traditional math scores will score on average this many points lower, and 4.8 points higher on a standardized test in traditional math classes. Okay, so it needs to be one of these two versions down here on the bottom. And then we need to figure out the difference right here, because the difference being negative at the start here means traditional might be higher. That would mean non-traditional could be this much lower or it could be this much higher. So in speaking of non-traditional, it might be that they're this much lower because that's the negative associated with traditional being higher, or they could be, it says on average. Oh, good. Yes. With a 90% confidence student this is a singular student. Yep, there it is. So it's not about a singular student, it's about the mean, and that's the difference right here. So a singular student is not the mean. We're talking about on average, and on average is the mean. So they're making an error talking about a singular student. We're talking about on average right here. So great catch, Kayla, another 100 points. So you got this down. And so since we're talking about on average, it's talking about the means. And next one, does the results suggest that the students, this goes back to the project. What do you notice about your interval right here? The difference between these two groups could be what? the true difference could hypothetically be what value, which is in the interval. It's in my interval. It might not be in yours. But since this is in the interval right here, this could be the true difference. So the true difference between these two groups might be 0. And does it suggest we'll have significantly higher scores? No. No, because 0, the interval contains 0. There is insignificant evidence of a different. We don't have sufficient evidence. So we think that there might not be a difference. You might be like, well, maybe the traditional's better. Maybe the not traditional's better. So I don't know. One could be better by this amount. One could be better by this amount. Or there could be no difference between them. So we see that there is no difference. Whew. Only one wrong today, but we fixed it because I misread the question. No, Puppet Shark, did we do okay today? We need to increase your volume. How loud are you, Puppet Shark? Let me look at your volumes on the screen when I see it. I might be able to click down to it. He's pretty loud. It's the yellow. It's pretty good right there. I think it may be quieter in my ears. But that's got it. Kayla, so this one makes sense right here. Excellent work, Kayla. Great question to end the day on it. That was a really good final question watching the levels. That's pretty good. Chill background music. Like it. You're welcome, Kayla. Excellent work. Keep asking those questions. We did a lot today. A lot of great work. We're going to be streaming class here in 14 minutes. I'm going to go grab another snack. I'll see everybody then. Bye for now. Bye.